In this video, we are going to be finding extrema. So an extrema is like a maximum and a minimum. You can have local maxes and local minimums, and we are going to get to all of that here in a minute. Before we do that, let's just kind of review some things. So we're going to be looking at each one of these columns. So this is all related, and then this one is all the same thing. And then this one over here is the same thing. So we just want to fill this out. So if we look at this first column, they give us the factors of x plus 5 times x minus 1. The solutions, this is when you get x equals a number. So your factors are written in parentheses. Your solutions are x equals a number. You get your solutions from your factors. So you could just set each one of these equal to 0 and solve. So I would have x plus 5 equals 0 and x minus 1 equals 0. To solve this one, I would subtract 5 on both sides and get x equals negative 5. For this one, I'll add 1 to both sides and I'll get x equals 1. Your x-intercepts are your solutions. Remember, intercepts and solutions are the same thing. But typically when they ask for an x-intercept, they want it in the ordered pair form. So x comma y. When you have an x-intercept, it's always the number of your x-intercepts and then 0 for y. That's how you get it on the x-axis. So for this example, with solutions of negative 5 and positive 1, one of my x-intercepts would be the point negative 5, 0, and the other x-intercept would be the point 1, 0. And then to find your equation, all you need to do is just multiply out your factors. So this is going to be y equals, and then you can either do the area model or you could use FOIL to multiply these together. So if I multiply these together by using FOIL, first is x times x, which is x squared. Outside is going to give me negative x. Inside is going to give me 5x. And then last is going to give me negative 5. So let me just move this up a little bit. Oops. There we go. And then if I combine like terms, you get y equals x squared plus 4x minus 5. And that would be your equation. That's what you're doing for this column here and this column here as well. You're just going to take the information that you're given and find the other things. So go ahead and pause the video and see if you can find those other pieces of information. So in this middle column, they give us x equals positive 4 and negative 4. That's why we have that plus or minus here. So if it helps you, you could rewrite that as x equals positive 4 and x equals negative 4. I can work backwards and figure out what the factors were. So if I have positive 4 as a factor, that means I must have had x minus 4. Or I should say, if I have x plus 4 as a solution, then that means that I had x minus 4 as a factor. And if I have x minus 4 as a solution, then that means I had x plus 4 as a factor. Here, if you were to solve this, right, you would have x minus 4 equals 0. Add 4 to both sides, and that gives you the positive 4. Here you would have x plus 4 equals 0. Subtract 4 on both sides, and that's how you get negative 4. So we're just working backwards from that. To figure out your x-intercepts, well, that's just going to be positive 4, 0 and negative 4, 0. And your equation comes from your factors. So I'm just going to multiply those two binomials together. To do that, you can either use area model or FOIL, whichever you prefer. If I use FOIL, first, x times x is x squared. Outside, x times 4 is 4x. Inside, negative 4 times x is negative 4x. And then last, negative 4 times positive 4 is negative 16. So my equation is y equals x squared minus 16 because 4 minus 4 is 0, so those cancel. And for this last column, if I have negative 2, 0 as an intercept, then that means that x equals negative 2 as a solution, which means that we have a factor of x plus 2. Because the only way to get a negative 2 here is if you subtract it from both sides. For this one, if I have an x-intercept of 3, 0, then that means that I had a solution of x equals 3, which means I had a factor of x minus 3. Because the only way to get a positive 3 here is if you add 3 to both sides of your equation. So then up here, if these are my factors, I can use that information to figure out my equation. X times x is x squared. X times negative 3 is negative 3x. 2 times x is 2x. And 2 times negative 3 is negative 6. So my equation would be y equals x squared minus x minus 6. So that's a nice little warm-up for us as we move into our extremas. So it says label the extrema of the following curves. So either local minimum, local maximum, absolute minimum, or absolute maximum. If we have a quadratic, so this is a parabola, and we know that because it's of degree 2. Here I only have one vertex, right? And this would be out of these four, local min, local max, absolute min, and absolute max, this would be an absolute minimum. Absolute means it's at the lowest or the highest. So in this case, this is the absolute minimum value. We never get smaller than this point right here. You would have a local max or a local min like here and here, because here this is a maximum, but my graph gets higher than that. And here this is a minimum, but my graph gets lower than that. So local max and local mins means that it is a maximum or a minimum for that localized spot. And absolute max or min means it absolutely gets no lower than that, or it absolutely gets no higher than that. This point right here is an absolute minimum because we absolutely never get lower than this point right here on this graph. I don't have any local mins or maxes because I don't have any other vertices here. And here I have no absolute maximum. And that's because my graph is going up forever. So I'm never going to get to the maximum because it's just going to keep going up and up and up and up forever. We'll never get to the end of the graph. So here we have no absolute maximum. For this degree 3 cubic function, this is a vertice, and this would be a maximum because it's the top of a mountain, and this would be a local maximum. It's not an absolute maximum because my graph does get higher than this point right here. So because this isn't the absolute highest point of the graph, it's just a local maximum. This point right here is a local minimum. It's not an absolute minimum because my graph does get lower than this point, right? My graph is going to continue to get lower forever. So that makes this a local minimum. Notice on this one, because my graph is going up forever and because my graph is going down forever, I have no absolute maximum or minimum. And then if we look at this quartic function, this point right here is a minimum. Is it a local min or an absolute min? This is an absolute minimum because it absolutely never gets lower than this point. This graph is going to continue up forever, and over here it's going to continue up forever. It's never going to get lower than this point right here, making this an absolute minimum. This point right here is a local maximum. It's the highest point of the graph for right here, but my graph does continue up forever, so it's not the highest point of the graph. And then this point right here is a local minimum. It is the smallest point of the graph at this location, but it does get smaller, so it's not absolute. In this problem, we had no absolute maximum. You can have an absolute max, you can have an absolute min, you can have just local max and mins. It all depends on the graph that you're given. So let's look at some of these on the next page. It says type the polynomial function into Desmos.com. Adjust your window as needed, so you can just zoom in and zoom out. Sketch the function and label the extrema and the intervals of increase and decrease using interval notation. Now I want you to think back to Algebra 1. When you're doing interval notation, remember that these are just your x values from left to right. Your interval notation is when you use parentheses and brackets. So let me show you what I mean. Down here we have some reminders. Remember, use a bracket if it is equal to the number and use parentheses if it is not. Always use parentheses with infinity. So if we look at this first one, we have x plus 3 minus 4x plus 4. Let me just grab my thing so I know where I am. All right. So I'm going to pull up Desmos. So you just go to Desmos.com and you're going to click on the graphing calculator. And I'm just going to type in that equation. So I have x cubed minus 4x plus 4. And I'm just going to go ahead and sketch this graph on my sheet of paper. I want the same shape, but I'm not going to worry about drawing the coordinate plane or anything like that. So over here, my graph went up and then down and then back up again. Make sure you draw your arrows so that you know that your graph continues on this way forever and it continues on this way forever. The reason why I love Desmos so much is that we can click on the points to find exactly where they are. If we were using a TI-84 graphing calculator, we'd have to do a couple steps to do that. So this is a lot more user-friendly. This point right here, let's just round to the nearest tenth. So that's 1 decimal spot. So that's going to be the point negative 1.2. And when we're talking about, I just lost my train of thought. When we're talking about interval notation, we're only talking about your x values. So I'm not worried about the y value here. I just want the x value. So at this point, x is negative 1.2. Now let's figure out what x is at this spot. So in this one, again, we're going to round to the nearest tenth, so that's also 1.2. And again, I'm just looking at the x values. So this is at 1.2. Is this point a minimum or a maximum? It's a maximum. Is it absolute or local? Well, my graph does get higher than this point right here, so that makes this a local maximum. So I have a local max, and then that was at the point negative 1.2, and then let's get that y coordinate, 7.1. Is this point right here a maximum or a minimum? It's a minimum. Is it absolute or local? Well, my graph does get smaller than this point right here, so that makes this a local minimum. And that local minimum occurs at the point 1.2. And then if I round that to the nearest tenth, that's 0.9. So those are my extrema, your max and your mins. For interval of decrease and increase, we're only looking at the x values. Now remember, for interval of increase, that is when it is going up from left to right. So let's look at this graph. I'm going to start at the beginning. And when I go from here to here, do we go up or down? We went up, so that's the interval of increase. For this next part, do we go up or down to get from this point to this point? Well, we went down, so that's an interval of decrease. And then from this last part, to go from here to the end, we go up from left to right. So that is another interval of increase. So I'm going to go ahead and write my intervals using interval notation. Now on my number line down here at the bottom, negative infinity is always on the left and positive infinity is always on the right. So if I look at this first one over here, we are increasing. So look at your x's. You are increasing from negative infinity to negative 1.2. Negative infinity always gets a parenthesis. Negative 1.2 is also going to get a parenthesis because for this next part, it's decreasing. And negative 1.2 cannot be increasing and decreasing at the same time. So if it's a point of inflection where it switches from increasing to decreasing, you will also use a parenthesis. This next section here in the middle is decreasing, so I'm going to skip that for now, and I'm going to continue on with the interval of increase. So I am increasing from 1.2 to infinity. 1.2 gets a parenthesis because it's changing from decreasing to increasing. Infinity always gets a parenthesis because we can never get there. And then if we look at our interval, whoops, I wrote that in the wrong spot. I'm sorry, this is an interval of increase. And then for our interval of decrease, we are decreasing here in the middle. So we are decreasing from negative 1.2 to positive 1.2. Negative 1.2 gets a parenthesis and positive 1.2 gets a parenthesis, because this is where it's changing from increasing to decreasing. When you're doing your extrema, these are written as ordered pairs. In your intervals of increase and decrease, these are written in interval notation. So when we're doing that, we're only doing the x's. Let's try this again with example 2. So on example 2, we have f of x equals x cubed minus 3. So I'm going to go over to Desmos, and I'm just going to type in x cubed minus 3. And this is what the shape of that graph looks like. So let's go ahead and draw that shape. And we want to find our extrema. Your extrema are maximum and minimum values. It looks like maybe I have something here, but it also looks like I'm continuing to increase the whole way up. I never go back down. So let's see that on Desmos. And again, this is a reason why I love Desmos so much, is that you can click on it and you can see your different points here. So if I look at my x values, I'm looking to see if my x values ever go back down. So it might help if I zoom in a little bit more. So here we're looking at our x values and they are increasing. They're still increasing. I haven't gone back down yet. still increasing, still increasing. They're continuing to go up. So we never dip back down. They're always increasing. And so because it's always increasing, we don't have any maximum or minimums. So we just say none. We just said that it's always increasing because it is going up from left to right the entire time. It never dips back down and the numbers never start to decrease. So you're increasing over your entire domain, which is from negative infinity to positive infinity, right? Negative infinity is on the left, positive infinity is on the right. We are increasing over that entire interval. We never go back down, so we do not have any intervals of decrease. Let's try this again with another one. Here we have x to the fourth minus x squared plus 6. So, x raised to the fourth minus x squared plus 6. And I need to just zoom back out. And here is my graph. So this one is W-shaped. Go back over here, and I'm going to draw that W. There we go. So I can see that I'm going to have some extremas here, here, and here, right? So let's figure what those are. So this first one is the point, we're just going to always do the to the nearest tenth, so that's 1 decimal point. So here that is negative 0.7. Let me go back over here. So let me get the ordered pair. So it's negative 0.7, 5.8. Negative 0.7, 5.8. So my x value here is negative 0.7. Is this point an absolute min or a local min? Well, we're not sure yet because we still need to figure out if this point is lower or the same. So for right now, we'll just call it a minimum for right now until we have all of the information that we need. And then if we look at the next point, this is the point 0.06. And the 0.06 is a local maximum. I know it's local. Oh, I wrote minimum. I know it is local because my graph continues to increase on either side. So it is not the absolute highest point of the graph, but it is a local maximum for this point right here. So, and that is where x is 0. So again, this is a local maximum. And then for this last point, we're going to go back over to Desmos. And this is the point 0.7, 5.8. These two minimums have the same y value, so they're at the same height. So they are both the absolute max. Or sorry, I mean absolute min. Because they're the lowest points. So this was where x was 0.7. And so we said that this is an absolute minimum and that this is an absolute minimum. And so that is at the point 0.7, 5.8. They are both the absolute minimum because they're at the same exact height for the y. If this one was lower than this one, then this would be the absolute min and this would be a local min. But because these are the same level, And if I show you back over here on Desmos, because these are both at the same height, they are both the absolute min. So now we want to find our intervals of increase and decrease. So if I look at my graph from left to right, my furthest point all the way over to the left, if it keeps going to the left forever, that's going to negative infinity. And if I keep going to the right forever, that's going to positive infinity. So from left to right, I'm going down. So I'm going down to get to that first absolute minimum. That's an interval of decrease. So I'm decreasing from negative infinity to negative 0.7. For the next part, I'm going up to go from the absolute min to the local max. So this is an interval of increase. Here I am increasing from negative 0.7 to 0. So negative 0.7 to 0. And then to go from the local max to the absolute min, we go down from left to right. So again, I am decreasing. So I am decreasing from 0 to 0.7. And then to go from the absolute minimum to the end of my graph, I'm going up from left to right. So I'm increasing from 0.7 to infinity. So again, here we were decreasing, increasing, decreasing, increasing. Whenever you have a spot that is increasing and decreasing at the same time, you're going to use parentheses there. And every time you have infinity, you're going to use parentheses. This would be my answer for this one.